I am on page 209, and we are looking at example 1. Now, if you have the textbook, you can go ahead and see what I'm doing here. But for those of you who may not have the textbook or who may prefer not to look at the textbook, I'm going to set this up very much step by step. So here's the story for this problem. Allison and Leah competed in a race. The graph and equation describe their race performances. Who ran faster, Allison or Leah? So then we're given a graph called Allison's race. And you can graph this with me. It's good practice. Or you can just watch, whatever you want to do. You only need quadrant 1, which is usually going to be true if we're talking about a proportional relationship. And we're going to graph time in minutes as our independent variable. Against distance in miles. Okay. And we've got true 0, 0, 0. And then we have 20, 40, 60. So there's the 1 hour mark. And then 80 minutes. And then on the y-axis, we have a 3, a 6, a 9, and a 12. Okay. And here are some points. We have a point at 0, 0, so we meet the 0, 0 principle. And then we have one at 9 on y and 60 on x, so 60 and 9 right here. And if we have 2 points, we can find slope. So that's going to be my next order of business. There is the function that represents Allison's race. And it actually just looks like this. So let me keep it true to the example. It's just going to look like that. So we have 0.00 and we have 60 and 9. All right, so you can use rise over run if you want to get slope. Let me remind you of how that works. You would rise 9 miles and run 60 minutes. So the slope would be, just using rise over run, you rise 9 miles and you run 60 minutes. Now, if you wanted to find a unit rate, you would say, what is 1 minute? So you have 9 times 1. That's the first step, and that's 9. And then 9 divided by 60. Oh my, where's my calculator? Well, it's in the book if you have the book, but 9 divided by 60 is 0.15. So 15 hundredths of a mile in 1 minute. And that would be called our unit rate. Now, once you get the unit rate, you know K. The constant of proportionality, which is also the same as your slope, is 0.15. So that is telling me Allison's story. Allison's is given to us in the form of a graph. So now I give up. Now let's look at Leah's race. And I'm going to move this just a little bit so I have room to get all of my other stuff in here. And Leah's race Okay, this is interesting. Is D equals 0.1 t, where D represents the distance in miles, and T represents the time in minutes. So we have miles to minutes again. So we can substitute the same. Let's not even substitute. Let's just talk about it as here's your rise, here's your run, and there's your slope. That's slope, and that is also the letter K. So we could say that M is 0.1 or K is 0.1. So now we have what we need. Once you get that unit rate, you are good to compare. So I'm going to compare the slopes. And we have 0.15. That goes with Allison. We have 0.1, and we can put a ghost 0 there. That's Leah. So which number is greater? Is it 0.15 or 0.10? Allison's number is bigger. So Allison is faster than Leah. You could also say that Leah is slower than Allison. Okay. And that was the question. Who ran faster, Allison or Leah? So I would say that Allison ran faster.